So in this question, we want to take these 6 batteries, each rated at 6 volts, and create a source that's 12 volts and lasts a long time. Now we know when we place batteries in parallel, the voltage doesn't change, but every time you add another battery in parallel, you extend the life of that power supply. So every time I put a battery across another battery, it doubles the life. If I put 3 batteries together, it triples the life, assuming they're all identical batteries. Now when I put them in series, we add up the voltages. So if I put 2 6-volt batteries together in series, we get 12 volts. Now this is a combination. We only want 12 volts, so we know we're going to take 2 6-volt sources and put them together in series. But we also want them to last a long time. So each of those individual 6-volt sources, we're going to convert into a parallel section to make each of those sources last 3 times as long. So I'm going to take the first set of batteries and connect them all in parallel. And in parallel, you put all the negatives together and all the positives together. So all these negatives on the left, the short symbol on our schematic, and all the positives on the right are all going to be connected together. Similarly with the 3 batteries on the right-hand side of this picture, I'm going to put them together in parallel. Connect all the positives and all the negatives together. So what I've got here is a 6-volt source, but lasts 3 times as long, and another 6-volt source, but lasts 3 times as long. And I want to take those and connect them together in series. And in series, you connect positive to negative. So notice all of these positives on the source on the left, we're going to take those and connect them to all the negatives for this parallel section on the right. And then we're going to take the circuit and, as usual, power a light bulb. So I'm going to draw a wire down like that, and we'll put a light bulb in our circuit somewhere like that. So there's the schematic we want to reproduce. So let's label these batteries A, B, and C. And connect them together on the left-hand side first. All the positives have to be connected together. So all these red terminals which are positive, I need to get a wire connecting each of them. All the negatives have to be connected together as well. So far I've done this. I've connected all the positives together. And now I want to connect all the negatives together. So I'll use red for that. Negative to negative, negative to negative. So I've done this now. Similarly on the right, we want to connect all the negatives and all the positives together. So the diagram is going to look very similar on the right. Positives are going to be connected together. So that's these things on our schematic. And then the negatives is just like we did in the previous one. So negatives and negatives, we're going to connect those posts together. All right, now what about in between the batteries? The positive, the blue wires from our first bank are going to be connected to the red wires of the second. Notice it doesn't matter which post we connect it to because they're all connected together anyway. Similarly, it doesn't matter where we start, which post we start at, they're all connected together anyway. So I'm going to take, and I'll just do it in green here, positive terminal to negative terminal. So that's this green wire in the middle. Now the only thing left is to connect our light bulb. So from the positive terminals, which are blue wires on the right-hand side, we need to connect a wire to one side of the battery. So I'll use yellow for that one. So we're going to connect one side to our light bulb. So this represents our light bulb that we're going to try and power with this circuit. Again, I'll just clean that up a little bit. Here's our light bulb. And on the other side of the light bulb, let's use black this one. On the other side of the light bulb, we're going to take it all the way to the negative terminals of the batteries on the left-hand side, which are our red sides. So anywhere to any red post will finish the circuit. So if I label this last one, let's call it wire number 6 on my diagram. This is wire number 6 right here. Just so we keep track. And now we finished. We've got a battery that lasts really, really long, and it's equivalent to 12 volts powering a light bulb.